Hello, my name is Joe Valencic. I'm a professor of marine science and technology at Saddleback Community College and also principal investigator of the Crystal Cove Underwater Research Project. Our ranger will show you the interior of the park, but I'd like to share with you the beauty of this underwater paradise. So, welcome to Crystal Cove. The underwater research effort at Crystal Cove involves the monitoring of both marine invertebrates as well as fish to determine both the abundance and the type present within the park's boundaries. This is the purpose of today's research dive. The information that we gather from this baseline data will be used to assess the changes both from Mother Nature as well as man. The information will also be used to determine underwater trails for divers within Crystal Cove State Park.
Sensitive to predicted high human impact on coastal environments, the California State Park System has initiated this one-year underwater research project at Crystal Cove. Assistance for the project has been provided by various marine scientists, in addition to marine technology students from Saddleback College. Also supporting this effort are certified state lifeguard divers and boat operators from Newport Beach.
Hi, I'm David Perry. I'm the skipper of Surfwatch 1. Surfwatch 1 is a lifeguard vessel, 32 feet long. In the summertime, we operate off the coast, off state parks, rescuing swimmers, usually in riptides or in large surf. In the off-season, we are assisting the underwater research effort off Crystal Cove State Park. And we do that by assisting the divers with their video camera and transect lines. And that's what we're going to be doing today, so hang on.
The marine portion of Crystal Cove Park encompasses over 1,100 underwater acres from mean high tide seaward to a depth of 120 feet. The 3¼ mile long sandy beach is interspersed with scattered rocky outcroppings and rich intertidal areas. Park boundaries extend from Cameo Shores in Corona del Mar south to Abalone Point in Laguna Beach.
Well, conditions look pretty good today, Dave.
Yeah, they sure do.
Let's go to Hatchet Cut Reef. That's one of our 4 monitoring reefs out at Crystal Cove. I think it's out in this area. The base of Hatchet Cut Reef is in about 70 feet of water. It's a sandy bottom. The reef ledge then extends up to a top of the pinnacle about 42 feet. Here you can see some of the spikes, some of the little overhangs on it, and then drops off in the far side. This is only one of 4 areas that we're monitoring at Crystal Cove.
With the reef located and anchor deployed, Bill Tippett's ecologist for the State Park System discusses the park.
Crystal Cove is the most recent of the underwater state parks to be developed. We're very excited about this state park because we're participating in some research to determine the biological values of the underwater area using underwater television techniques as well as state-of-the-art computerized data processing. All of this information will be developed and brought to the visitor center where the non-diving public will gain a better appreciation of the underwater state park.
Good.
Okay, this is what the reef structure looks like at Hatchet Cut. The top of the reef is in about 40 feet of water. Dave, you'll be going down first. On the reef, we've epoxied some of these PVC stakes. So I'd like you to locate these stakes on the reef.
A pre-dive briefing outlines specific tasks for each diver. Underwater skills involving biology, geology, navigation, photography, and video are important qualifications for all divers participating in the project. Some of the sophisticated equipment used for underwater data recording has been developed specifically for this underwater research project.
Communications mask, and the way that we've got it set up is the output of your microphone will go into a voice-actuated microcassette recorder. So information on the type of animals and their densities will be automatically recorded on this. We can take it back in the laboratory and then evaluate it by computer directly. So this will be your function. I'll follow you fellows around. I'll also be wearing a full face mask for communications, but I'll be putting it into the audio plug then of an underwater video system. So my job then will record both the video images as well as narration for the underwater sound. So we again can take that back and look at the data. Any questions? No. Okay, let's go diving.
All right. Thank you very much.
We are descending. Water visibility somewhat reduced and greenish in color due to a marine algae or phytoplankton bloom. Surface water temperature is 64 degrees Fahrenheit. Thermocline at a depth of 40 feet. Reduced water temperature to about 61 degrees Fahrenheit. We've located the reef at 55 feet and have established a temporary transect line so that generalized features on the geological structure as well as the fish and other marine communities that live here can be recorded. For this task, divers use clipboards with special waterproof paper. We'll now swim over to the southern extension of this 100-meter long reef, and I'll point the video camera downward onto the reef base to show you some of the marine life at this location. In the foreground, several different species of fan-like Gorgonian coral, isolated patches of smaller macroscopic brown and red algae. Great habitat for fish like this curious female sheep's head. Looking under the ledges off to the left, notice a giant red sea urchin. The topography of this reef is quite irregular and there are many fissures and ledges. This irregular structure provides a good substrate for algae as well as a wide variety of marine invertebrates to occupy. Yellow tufts, a colony of thousands of marine organisms known collectively as bryozoans. Near the top of the reef, 6 California Garibaldi. Swimming the video camera along the reef top, water depth 30 feet, 2 giant spine sea stars. The entire reef is blanketed by a dense mat of competing marine organisms. Scientists estimate there's approximately 1,000 or more different species of marine organisms within the park's underwater boundaries. Because of the more favorable conditions, the reef top has about 6 times as many individuals. That pointed out here is a large rock scallop. Unlike the swimming scallops, this rock scallop cements itself to the reef and retain their filtering food. Looking under an undercut ledge here, one of 3 different species of California Gorgonian coral, this being the California golden Gorgonian, the most dominant. Also, back under the ledges, several more giant red sea urchins. These overhangs and undercut ledges can be quite spectacular for divers. The large brown algae not only add to the underwater beauty as they sway in the current, but also afford protection for many fish and other marine organisms. This brown Gorgonian soft coral is easily recognizable by its distinct white polyps. Here the California golden, also a protective habitat, much smaller scale. Now, to assist in the survey of large reef areas, we use diver propulsion vehicles like this small Techna scooter. Conserve divers' energy and air. They increase underwater time. Been valuable in exploring areas adjacent to Crystal Cove and establishing some of our underwater monitoring sites. Now, returning to the reef, swimming northward through a small school of blacksmith fish. Appears that one of the divers located a spare line on the bottom. Move in closer with the video camera. Well, not too bad. Connected to the line, a Danforth anchor. Probably some poor fisherman lost on the reef. These small blacksmith fish, often found in schools, 100 or more, have a very unique habit. During the day, they're normally seen above the reef, feeding on plankton. Late afternoon, they move downward to the bottom of the reef and seek the protection of these small caves and crevices to spend the night. They are a member of the damselfish family, quite common in Southern California waters. Other common fish are the sheep's head, kelp bass, and senorita wrasse. The territorial and feeding behavior of these fish can be studied close up by luring them into the camera's field of view. Narration from other underwater scientists wearing full face masks like this Curry Morgan shown here can also be linked to my underwater video camera. In this study, Dr. Bob Given can observe firsthand sheepshead feeding behavior. The sheepshead has very protruding teeth, able to move in and feed despite the urchin's long spines. Urchin roe or eggs are consumed while waste is expelled. Underwater 35mm cameras and strobes are also used to document the reefs. There will be both used in our study as part of an underwater guide for Crystal Cove. On camera is a giant keyhole limpet between 3 sea stars. The sea stars consume large amounts of bivalves such as rock oysters. This sea star, held by ecologist Bill Tippett, is just one of about 50 different invertebrates and fish being monitored as part of the research project. Bill is pointing to the extended stomach of the sea star, indicating it was feeding prior to its removal from the reef. Now we'll place it back on the reef so it can continue its dinner. Another monitored organism is this tube anemone. Here a diver places a small clamshell in the vicinity of the anemone to elicit a reaction. There is none. Small section of drift algae is gently brushed against the anemone's tentacles. Still no reaction from these normally encountered substances. However, a sharp metallic object, such as a diver's knife, when contact is made, causes the tentacles to instantly retract back into its protective tube. Many marine animals have outer protective structures. This wavy-top turban snail has both a hard calcium carbonate shell in addition to a small trapdoor shown here known as an operculum. It can be withdrawn in the shell, closing it off and protecting its muscular foot. Another interesting thing about this shell is it has several small plants growing on it. As the shell moves, attached plants and animals become redistributed then across and among the reefs. This long-spined urchin, Centrostephanus, belongs to the same family as the poisonous urchins in the tropics. Fortunately, this species is not poisonous. The long spines make the urchin appear much larger than it really is, also making it very difficult for fish to break it open. Turning it over, there are suction-like tube feet used for attachment to the bottom. These 2 feet, as well as the short spines, help the urchin move along the bottom. It can be quite active. The white central area is the urchin's mouth. There are 5 jaws with 5 bony teeth that come together in the center. They articulate these jaws to feed upon various algae. This is an octopus we've lured from a small crevice in the rocks. It's quite unhappy to be held by the diver and discharges a dense brown ink or fluid to create a protective smokescreen. Garibaldi would love to make this octopus its next meal. Normally, octopus use their 8 tentacles to move over the rocks. Here it's using it to move over the diver's masks, discharging ink. Octopus has a high degree of intelligence, can be a slippery creature though. This California spiny lobster lacks the large pincing claws of the Maine lobster. It's still a popular food and can grow to a length of about 30 inches. It uses its long antennae and short antennules in searching for food as well as for protection. They are in almost constant motion. Lobsters normally hide in rocky crevices but venture out at night in search of food. For protection, its body is covered with sharp spines similar to thorns on a rosebush. The entire underwater park at Crystal Cove is designated as a marine life refuge, and from the video footage, I'm sure you'll agree it's a very beautiful one. The marine areas within the park include some of the finest reef environments in all Southern California. Hopefully, this research effort will assist both in understanding as well as preserving this valuable resource for future generations to appreciate.
With underwater work complete and gear stowed, divers compare notes on the stern of the Surfwatch.
Okay, what do you think? That was a pretty good dive.
That was great. There was a lot of life down there.
Water temperature was about 64 degrees. We had 30 to maybe 35-foot horizontal visibility, so I think conditions were
Hundreds of
excellent.
scientific dives such as this have been conducted in support of the underwater research effort at Crystal Cove.
Good pictures that we got.
I know that Scott is going to take my picture, so the air supply on that will terminate this little transect.
With underwater audio and video field data obtained, results can now be reviewed in the laboratory and entered directly into a computer. Many of the computer programs have been developed specifically for Crystal Cove to statistically analyze and illustrate all field data. Saddleback College science students provide valuable assistance for data entry and analysis. All monitored invertebrate and fish populations become part of an extensive database. The reports generated reflect environmental changes, providing a basis for prudent resource management. This management also applies to the intertidal area, which is ecologically very important for hundreds of different marine species. Life in the intertidal zone is a constant challenge, a perpetual struggle for survival between extreme fluctuating environmental conditions and varying degrees of human impact. Intertidal research at Crystal Cove involves photographic and video documentation of selected areas. 40 specific monitoring locations have been established. A special epoxy is used to permanently mark each study quadrant in 4 different intertidal zones. Numbered brass tags are made on site and embedded in the epoxy, identifying each quadrant. All sites can be relocated using distance and bearing data from a known reference mark in both the Reef Point and Treasure Cove study areas. 35mm and video cameras are used on PVC tripods to obtain permanent records of marine plants and animals for each monitored site at 6-month intervals. Tide pool animals like these hermit crabs survive in a harsh environment but are also sensitive to human interference. Since Crystal Cove is a designated marine refuge, intertidal animals may be observed but not taken or disturbed. Burrowing ghost shrimp are often found in the shallow, sandy intertidal areas. Although they possess a single large claw or pincher, they are not aggressive animals, but would rather return to their burrows. Many varieties of small turban snails thrive in the shallow intertidal area. Their muscular foot, shown here, can be withdrawn completely into their protective shell. Empty shells quickly become a home for hermit crabs. Although quite curious, hermit crabs will quickly withdraw into their borrowed shell if alarmed. This highly visible orange bat star is a scavenger and will congregate in large numbers to feed on other dying animals. Its relative, the brittle star, normally seeks the cover of rocks. Unlike other starfish, the female actually broods its eggs. Their long serpent-like articulated arms make the brittle star a highly mobile intertidal animal. Investigating a tide pool, turning over a rock, or carrying away specimens can have serious consequences to the inhabitants of this intertidal zone. However, with proper care, tide pool communities at Crystal Cove will continue to flourish for all to enjoy. Moving from the intertidal area to the beach, lifeguard Ken Kramer discusses the beach and diving facilities.
Some of the features that we have at our park is we have access by 4 paved ramps, which makes it easier for people to get down to the beach, and also access through the historic district or the Crystal Cove cottages. We have 1 staircase for access down to the beach as well. We serve approximately as many as 200 divers on a busy day during the summer and in the winter months. This is a popular area for dive schools to come down to, and some of the programs that we can offer here as the park staff is we can give guided tours. We hope to, in the near future, be giving underwater guided tours with our dive team members, rangers, and lifeguards. The varied terrain that we have both on the beach and underwater attracts many different people down here. For the diving community, we have sandy areas as well as beautiful underwater reefs. We have spectacular areas for both the novice and the advanced diver, as well as the game fishing diver and photographers alike. We have a park headquarters where we're going to have a full interpretive display of the underwater park and the features that we have here.
Park headquarters, located on the inland side of the Pacific Coast Highway, is where we caught up with park ranger Ken Smith.
The facilities here at Crystal Cove include approximately a total of around 2,760 acres, of which 2,350 are in the backcountry, Omaral Canyon. In El Morro Canyon, in the future, we intend to have an equestrian concession. We're also going to be putting in 32 environmental campsites. These will be for hikers, for bicyclists, and for equestrian use. They'll be located in 3 separate areas in the backcountry. The backcountry consists of about 17 miles of trails that are open to the public. 2 of these trails go up either ridge, the El Morro Ridge to the south and No Name Ridge to the north.
For those interested in bicycling, horseback riding, or just hiking, the backcountry offers a quiet and serene area that seems to be caught in time. In addition to the 17 miles of trails, there is historic significance to this area, as explained by John O'Rourke.
Right now, we're back in the backcountry. We've got about 2,400 acres in this area, which has been set aside as a natural area in the San Joaquin Hills range here in Orange County. The unique thing about this park is this is the last natural area that's left in Orange County. We're surrounded on 3 sides by 15 million people, and on the other side we have the Pacific Ocean. Right now I'm at a place in the backcountry which is of historic significance. We've got 30 Native American sites inside the park, and one of those is right here. It's a Native American site which was occupied by Juaneño Indians approximately 4,000 to 9,000 years ago, and the Indians were present here in the park up until the 1700s when the Spanish started their mission system and the Indians left this area. As you go through the park, if you see different areas where you'll find shell deposits off the side of the trails and things, those are called midden sites, and what these are is when the Indians would go down to the beach and get mussels and things to eat, they would throw their trash out near their sites where they lived, and this is a good way to find an Indian site. And as I say, all through the park there's 30 known sites, and I'm sure there's many, many more. We're in front of a cave right now, and I'd like to show it to you. Okay, here we're inside a Native American site. Approximately, 200 years ago, the Juaneño Indians inhabited these hills. There was 3,000 or 4,000 of them that lived here inside the park boundaries. In the 1700s, 1776, right around there, the Spanish were exploring an expeditionary force up this coast, and they ran into the Indians. They established a series of missions, and one of those missions was San Juan Capistrano. The Spanish called the Indians here in this area Juaneño Indians, and to this day we refer to them as the Juaneño Indians. As you come to the park and go through the backcountry, it's almost like traveling back in time. If you can see one of these caves or just let your mind wander a bit, it's like maybe being back before this area was developed.
We hope your visit to Crystal Cove will be an enjoyable one. Its terrestrial and underwater resources have much to offer, making it a welcome addition to the California State Park system. This pristine coastal marine environment of Crystal Cove stands as a jewel, open to the quiet tranquility of the Pacific. It is truly an ocean lover's delight.